Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
or consumption of software-based solutions.
You'll hear stories of what worked
and sometimes what didn't.
You will also hear very personal experiences
and insights that would trigger your thoughts
and inspire you to do even greater things.
Before we jump into today's conversation, a special thanks to PM Power Consulting for encouraging and supporting this show right from the start. With over 1,000 person-years of collective experience, PM Power has helped many organizations, teams, and individuals chart out their own journeys of excellence and make progress. Thank you, PM Power. Now, let's move to today's episode.
It's been a while since I, Chitra, your co-host on the Software People Stories, recorded any episode. So when I met Chakkirala, AI Solutions Architect, after many years at a conference, we reconnected quickly, thanks to the busy or steaming topic of the past 3 years, emergence of artificial intelligence and its pervading our thoughts and daily lives. She quickly agreed to feature on our podcast. So this conversation covers her early forays with data science, dealing with big data and distributed systems, and how she started building supervised models around DNS threat detection and storage optimization. Explainability of AI is something she wants to bring to everyone. So she talks about the inspiration behind her book, Interpretability and Explainability in AI using Python. So listen on. So good afternoon, Aruna. I am really happy to have had this conversation with you. I have interacted with you as part of the fond and memorable GHCI working group and committee that we were both part of for many years. So I'm absolutely delighted to welcome you to the Software People Stories podcast and looking forward to this conversation. Warm welcome to you.
Yeah, thank you. Thank you, Chitra. Definitely a pleasure to be here.
Okay. So, Aruna, we usually start our podcast by asking our guests to tell us a little bit about themselves. How would you like to introduce yourself to our listeners?
Yeah, so let me start with what I'm doing now before I get back into what led me to where I am today. So I'm currently working as an AI solutions architect at Microsoft. Primarily, my role entails working with partners and customers on envisioning AI solutions as well as building and architecting them. The goal is to build successful applications. Of course, the past 3 years has been a lot around Gen AI. That's my current role. When I look back at how and where I came from, I think it all started way back. Curiosity, I would say, has been my biggest driver. Being an avid reader, all of those played some kind of a role in how and where it took me. Reading is something I still get back to all the time, keeps me going all the time. Yeah.
That's nice. Yeah. I am an avid reader too, so I definitely will ask you a few questions on your favorites. But Aruna, going back in time, did you always think that you were going to get into technology and computers? What got you started down that path? Was it always there when you were a child, or what helped you gravitate to that path?
Yeah, no, that's an interesting question because I think I don't have a very nice and rosy answer. As it happens, being an avid reader, I always imagined myself in multiple careers. At one point, I dabbled in some poetry, wrote some poetry. I thought I would probably get into journalism. A lot of thoughts, nothing really, concrete. And given that I was in a small town, I spent a lot of my childhood in a small town in Goa. It meant that my visibility or my influence areas were fewer. Of course, one big influence was my dad, but then he had his own set of early setbacks, I would say, as an orphaned, being orphaned early on. He spent a lot of time with his extended family, but one thing was clear: he had a lot of unfulfilled intellectual ambitions, which we kind of inherited as a family. I guess that was one starting point, which I mean, early on, I just took up the career path. Uh, Maybe it just happened. I got into a computer science degree, bachelor's in computers. I took it up. But the real turning point, I would say, in terms of how I drove my career happened a little later. In fact, second year of my bachelor's, we lost my dad overnight. So it was pretty sudden. But I think that was kind of what really changed me overnight. Um, One was, of course, my resolve was to be financially independent. That was my clear driver. And the second one was also how I approached the whole, process of learning and life. That was another big change for me. Um, I was, like I said, I was a reader. I loved quotes. There was one quote which kind of resonated with me for a while. It went along the lines, right? Like, so even if your dreams haven't come true, be grateful that so haven't your nightmares. And so it kind of made sense for a long time until that event. And then I realized once your nightmare is true, I think you have nothing to lose. So that was kind of a pivotal moment for me. From then on, I guess my perspective has changed a great deal. Of course, sometimes I've strayed from that. I have to keep reminding myself that it's the journey that's more important than the outcomes. So that's been my primary goal, and that's kind of what has kept me going along with my curiosity. So post my bachelor's in computers, I did my MCA, master's in computers, and I joined a startup. So my first role was in a startup called Unimobile. Uh, like I said, curiosity means basically I was ready for anything new. Anything new excited me. So in college, when I was studying computers, I was totally into networks. So luckily, my first role was also in networks at the startup, and that was my journey. Uh, Over the years, I think curiosity has been one big reason that I keep trying to find new challenges uh, within computers, within technology. It keeps happening. Luckily, the pace changes so often that there's always opportunity to keep learning and doing new things. Yeah.
Nice, wonderful. I think I'm definitely filing that quote that if your nightmare lives out,
Yeah.
then
Yeah.
you in a way you don't fear anything anymore.
Yeah. That's
You're ready to face anything that comes along your way. So powerful. Thank you for sharing it. Um, so from this startup,
Mhm.
uh, where did you move on to next? And where did your first exposure to working with data begin?
Okay. Yeah. So I mean, my start with the startup, Unimobile, was definitely exciting. I didn't realize it then, but I think I totally thrived in the culture. Startup basically means full autonomy, doing things end to end. Researching and implementing was the real fun part for me. I totally enjoyed it. Did some very fun projects like building protocols end to end with just an RFC. I don't know if you remember. In those days, you had something called as request for comment,
Yes.
right? One large unwieldy document.
Yes, I remember. I was working on the LDAP protocol, and there were two
Oh, okay.
RFCs. Definitely, even VPNs those days were
Yeah.
beginning to get built out. We had RFC. We actually had only RFCs for reference. There
That's
was
true.
no Stack Overflow or ChatGPT like today.
Yeah, totally. I mean, I think those were the days. I mean, different kind of experiences, but so that's where I started off. I built many protocols. I even got to build the DNS bind protocol for one
Wow.
of the projects. In fact, that's an interesting project also. But one RFC, and luckily I had an O'Reilly book of bind, but that's about it. But the learning was immense. I think that learning was immense. So this was actually,
What would you recall as some crucial learning moments from there? Because these are things that
yeah.
I've noticed sound very alien to the
Mm,
younger crowd today. But I can totally understand because we lived by O'Reilly. I remember IBM read
yeah.
books, requests
Mm,
for comments, and just a
correct.
limited
Yeah.
set of material from which you learned and then you implemented. So what?
So I would say one key learning definitely was that when you build depth in an area, you are able to not just build something, you are able to rationalize and reason on how things are working. And that gives you a lot of power because it's not just building one day and you move off, right? You have to also troubleshoot it, figure out how to make it better, maybe perform better. So that depth that you gain when you spend time to understand a protocol or a system end to end with the internal workings of it, I would say gives you a lot of leverage in the long term. In the short term, it feels like I want to quickly get this up and running. But in the long term, you will benefit from having the depth of having read the whole, protocol or a system end to end and knowing the nuances, right?
Yes,
So
yes.
I found that to be a very important part of, the learning journey. Yeah.
How did this experience help you with, let's say, troubleshooting going forward?
Key point, spot on. Actually, I would say that was when I realized that anytime I was troubleshooting, I mean, I will move on to my next experience at Yahoo, but that's where it really made a very pivotal, influence because my whole perspective in troubleshooting changed from having to quickly find problems, going through the logs to thinking, rationalizing and thinking through, right? Versus just jumping into the deep end kinds, right?
Yeah.
So that logical thinking aspect comes in because now you are not just thinking, how do I quickly solve this? You're trying to think, how do I solve it efficiently, figuring out where the problem could be, or could I solve, maybe fix it in a better way, or even performance is another area where these things play a lot of role in, right? Like if you understand what kind of resources the system is works best on, then you are able to make it more performant. Or those I think they are small tweaks that you don't realize when you're reading,
Yeah.
but if it's there in the back of your head, you know that some at the right point it will help you uh, build a better product, troubleshoot better, even approach problem solving in a more structured manner. I think that's been my experience primarily. Yeah.
Yes. Yeah. It sounds very familiar and a very much a shared lived experience.
That's good. Yeah.
What was your experience with Yahoo like, and what areas did you work on there?
So Yahoo was definitely a very good experience for me. I mean, when I joined the team, I was leading a team of a service engineering team, as we were called back then, for mobile and ads. Definitely exciting phase. We were working on really the cutting edge of systems back then, actually. So I don't know if you remember this phase. I'm sure you would be aware of it. You had this. Instead of using this large servers, we were cobbling, thousands of commodity servers to build these huge systems, right? So what that meant was that there was a lot of uncertainty and chaos in it, and that's where we came in. So my team was we were primarily responsible for the entire advertising systems across 12 to 5 data centers. This is very early on. I think even terms that we know of, be it big data or be it distributed systems, were yet to be coined. So they're very exciting. I learned a great deal by making mistakes, taking on bigger challenges. Big learning. I think even my early, I would say even this early initiation into big data ML started there. Because if you know advertising, so the early systems were primarily talking of, you know, just showing an ad, and then it became how do you show relevant ads, which meant ad recommendation, right? Which as we all know now is machine learning. But yeah, at that point was very challenging. And while we worked on, making sure the systems were up, performance capacity, as well as the deployment architectures, we had to get deep. We had to work very closely with the engineers. I spent days working with the engineers because it was also fascinating to see how the space was evolving and understand the systems in and out to make them work at scale, right? That was the bigger challenge in itself. So that's where I found that my depth in certain areas helped a lot, because suddenly when you have thousands of instances and you have to quickly find and troubleshoot a incident, you have to be very quick in figuring out how do I quickly find the problem versus laboriously going through the logs and incidents. So that I realized was very key, because then you have to rationally think, what do I need to look for to find the problem quickly? Of course, it's a learning. It didn't happen overnight, but definitely the more I worked on those kinds of scale and systems, I realized that the depth helps, and I kept working on that space as well. But yeah, definitely Yahoo was very interesting learning, as well as built a lot of I say performance and scale muscle. I call it a muscle because then you always approach problems thinking that what you have now is the start, but you have to also think of how does it work when it gets to a certain point or a scale or a next level of it, right? So that gave me a lot of learning. Of course, the peers were amazing. Great learning just being amongst such wonderful teams and peers.
Yeah, great. So I'm going to switch a little back and forth between past and probably present.
Okay.
So when you look at problems on performance and scale, and how do you see patterns recurring today? And how do you approach problems of scale and performance today?
So I would say, see, while it seems like a lot has changed, not too much has changed, right? Because the problems are still the same. How you approach it or the tools you use it are going to change for sure, but the problems are the same.
But the
For
volumes
instance,
of data have just gone up so much, right? Just this morning, I was having a conversation with a company, and they said that we generate close to 3 to 4 terabytes per day. So, and back then we were talking about 3 to 4 terabytes maybe in 2 years. But with that volume of data being generated, and the systems have to have right from ingestion to processing to analytical capability. We have all the tools, we have all the infrastructure. However, we still see performance and scale bottlenecks, right? However much we anticipate, plan, learn. So you said the problems remain the same. But with the volume of data and everything just exponentially exploding, what do you see happening, and what would you suggest? How would you suggest people look at it?
Yeah, so for one, of course, your point is right. The scale has, we're talking of very different scales now versus back then. But the underlying systems have also changed. Back then, you probably had CPUs and drives. SSDs came on later, and now you have much more ability to have distributed data and which can work much more efficiently between each other. So the underlying layers have also changed for that matter, right? We could use like the high-end computing, you could use different kinds of systems now versus back then. right? So that layer has definitely changed. But at the same time, we also have more tools now. Like a classic example is how can you use AI and ML maybe to identify anomalies within your data, or maybe uh, understand what data is even relevant to start with, right? Because when you have larger volumes of data, being able to tackle it efficiently becomes important. So yeah, I mean, I won't say that's the only way to handle it, but AI is definitely a quick and easy way to get a good sense of data, especially when you have large volumes of it. Uh, I mean, but otherwise, I think working at scale is still going to be a challenge, because again, as it's like that scale law, some kind of a law, I'm sure applies here as well. That
Like
as you
Moore's
are,
law.
just like Moore's law, Mars law, all of those definitely apply here, I'm sure as well. So, so the a lot of times as engineers, as designers, we start with POCs in constrained environments, looking at the functionality, but the big picture is never, in the initial phases. A lot of conversations start with very small, constrained, ideas and thoughts. Scale basically means going beyond that, right? Like when you're working at scale, you're looking at not just how does the data, if it's distributed data, how would it work at a distributed, from that point of view. Similarly, you're looking at how do you make it reduce the response time, right? Like make it a very customer friendly experience. So there are many, many small factors which come in, which is what you're looking at in terms of performance at scale, right? And it's not just about being able to handle like terabytes of data or millions of subscribers in a day. It's also about the experience you can create with your system at that scale. So there are many different parts to it. How do you solve it? I think some of them are very traditional systems that we have now. We have a lot of technologies, be it uh, like using, maybe if you're looking at data processing, this you could use your Spark and all of these technologies. Or so those are definitely the approach that you would look at processing at scale. But again, the challenge I think is also sometimes, do you need all of the data, or can you just focus on the data you need, which is where you're looking at introducing maybe an AI ML or right kind of approach to identify the data of relevance. Yeah.
So I wanted to flip this question slightly,
Okay.
because a
Okay.
classical way of solving something is like you described, Aruna, is
Mm.
you work in a small environment, you apply the constraints, you do a POC, and then you iterate on it, and then you say, okay, fine, you say that the system can scale or it will be performant. What if we were to flip it, and look at saying that, hey, if we thought of scale first, can we start by is it possible to actually tackle the problem at scale itself, a big one? So let's say we're talking about, um, very, very complex systems. And when I say complex system, it's not only technology, but there are multiple other actors in the system. There are multiple systems working with each other. So is it possible to start by thinking of a problem at scale itself?
I would say it depends on the kind of problem also, but largely it's good to have that big picture perspective early on. Because when you start with just looking at one single POC, right? Like a lot of the, like let's say you start with one file or 500 or 5,000 files, or data points. You are not expanding the problem to understand how will this extrapolate when you start having maybe more users or more transactions. So that thought should be there at the back of the mind when you start designing, because then you are not just thinking of how do I make this functionally work in this POC, but you also have a broad picture of how will this scale beyond this single POC, right? Then you are not just focusing on the task at hand, but you're also making plans on how do you take it to the next level. So that is definitely important to think big picture, right? You might still need to prove that it works functionally within the POC, because that's of course the first key point. But having that big picture of how will this scale, because that leads to having an I mean, very typically you also want to avoid disappointment both for yourself and your end customers, right? So having that big picture understanding of how do you take it to scale is important, right? Or knowing the variables involved, keeping track of the different parts that you need to control, right? Scale could be many different ways. Data is one of them. Compute, making sure the compute is available and can handle the kinds of transactions you're looking at, or even layers in and around it, right? Like you could have security, network, all of those should also be able to scale with the solution. So yeah, definitely design with scale in mind is the way I would approach it. Yeah.
Okay, nice. So we'll move on to your data journey. And when did you actually start, building and applying models like machine learning models or data models, either prescriptive, uh, predictive, those kind of models? When did that start for you? And if you can share some context in which they were used, I think that'll be very interesting and exciting for our listeners.
Yeah, so post my initial experiences, like I said, I'm always ready for the next challenge, and it so happened that so my entry into ML primarily is actually spread across many years. It didn't happen suddenly. So I developed an interest after a couple of things. I had an interesting statistics course. I tried out TensorFlow in an IEEE conference. I'd done some work in Apache Spark that also intrigued me. A number of things triggered it. I did many MOOCs, right? The online courses. I did a number of these courses, and that's when I got really interested and into it. And I did a lot of hands-on work as well. So my journey actually started, my initial roles was primarily in an cybersecurity company called Infoblox. So I got into a data science role there, data scientist role. I was primarily working on building models for cybersecurity, right? So basically, DNS security was their core area, as well as threat detection and areas in and around threat detection security. So basically, that was my role in Infoblox. I had a very amazing team there. Really, they were really very good in security, machine learning. Had learned a lot of it on their own, but great learning for me. I picked a lot from just being with the right team, right set of peers. Got some really good mentors as well in the prospect. The work we were doing, like I said, was a number of things, right? Like primarily the goal was to build models which could understand security, right? DNS is one common point where a common entry point for security threats, right? I don't know if you've heard this term C2C, command and control. So basically, a lot of security incidents start with a DNS IP, right? DNS server per se, but which comes in through a DNS, IP. So the goal was to really secure the DNS layer with as many different ways as possible. Interesting ways that you can bypass this layer was what we were looking at, and how do you curb it, find ways to alert the teams on how do you look at the threats in a different way. So those were the different parts of it. I mean, it's a very vast area, although it seems like there's not too much in it, but it was a very vast area, and we had some really great experts, right? Who were experts in the threat space, who had worked in that area for a long time. So I primarily was working closely with the team to build models. So some of them were supervised models, primarily centered around, identifying some kind of DNS threats, or even administrative areas like storage, right? Like making sure that we are not overshooting our storage. So building models to forecast the kinds of storage needs that we would have. So some of them were more practical, everyday requirements, while some were more centered on the security side of it. So I worked a lot in those areas. One of them was also a graph model. So basically, it was looking at graphing the DNS traffic patterns to identify uh, maybe there is some kind of anomalous traffic within it, or how do you identify uh, the patterns and make a sense of maybe which kinds of organizations are they coming from? Are they centered from the same kinds of layers? So the challenge there was tremendous, actually. I mean, when you have data, there are two kinds of problems, I would say, in ML. One is you don't have data, one is you have too much of it, and both are problems. Right? So mine was the second, the latter. So when there is so much of data, you have to be able to process it. That took an immense amount of time processing the data, and like looking at it from different angles, like um, when you look at DNS traffic, you're looking at things like maybe. I mean, it's a vast area. I'm like nowhere near the experts that I've seen around me. Like there is a possibility of DDoS attacks, but then there are newer, novel ways of doing DDoS attacks, like slow drip. So then your approach to looking at the data changes. So there are so many different aspects around it that uh, the patterns which make sense in certain contexts, which look anomalous in certain contexts, may not be the case. So that was the biggest challenge, and it was important to work very closely with the experts to understand how do I process the data, understand the data. And the idea was also that we don't just use the DNS traffic and the data, but we also merge it with third-party data. Like you have a lot of domain names which are, considered like we have ranked domain names. So then you have to be able to identify uh, the ranked ones versus the new ones. I mean, it's an extremely vast area. We couldn't really get into the details of it, but the the models I was building was primarily about identifying patterns within the DNS traffic and trying to find either anomalies or patterns which make sense, right? Like maybe it belongs to a certain kind of a system or a certain type of an organization, and then use that as a layer for alerting or incidents. So those were some of the models. Uh, I mean, that I worked there. I also moved into a role where I was building the data lakes, primarily because, uh, I mean, those days we didn't have as many platforms and tools as we have now to work with ML. So building that grassroots layer was just as important as, building the models themselves. So that was one of my motivations to really understand the whole peripheral areas as well. Uh, and yeah, so that was some of the things that I did at Infoblox. Good experiences, good learnings. And because I was at a point where the whole layers, platforms, and tools were also evolving, uh, again, there was a lot of learning to be done time and again to adapt and learn newer ways of working with the data and building the models here.
Wow, it's fascinating to hear you say that, because you've now done data engineering, you've done the data layer, you've done the ML layer. Basically, you've set up all the building blocks for an AI stack, if I may say so.
Yeah, and I think it is probably kind of done because I realized that it was important to understand all the parts. It was a decision done to really get hands-on and understand all parts of it, because end of the day, building successful systems means you build wholesome
Yeah.
end-to-end aspects all around it. Yeah.
So far we've sort of looked a little bit at the creation part.
Mm.
Now let's shift the conversation to the consumption part, right?
Okay. Yeah.
It's really nice to, and I guess all of us, at least I've had maybe not as much of a depth of experience as you have had, but worked in small pockets with respect to uh, you know analyzing the data that we have around us. For example, one space that I worked on also was to find patterns to detect issues, and so that you could raise alerts and you could prevent
Mm.
outage before it
Mm.
really happened. But it involved looking at different kinds of data. It could be system logs, it could be incidents, it could be, and I remember then there was something called a call home, which is basically that wherever the system was deployed in any environment, if they turned on the call home, it would actually report in the logs so that you could process it. So yes, it was a combination of
Okay,
having
that's
no
that's
data.
interesting. Yeah, yeah, yeah.
Yeah, and many companies would be reluctant to do that, right? Because even though we said we have ways of anonymizing your data, but we just want to be able to proactively service something before it actually takes place and prevent an outage or minimize a downtime. So in those various contexts, we've worked on things, and like you
That's
rightly
interesting.
said,
Yeah.
these were sort of done very under the hood, right?
Mm.
Typically, an audience that would adopt something like this or appreciate and understand the importance of it would be very specific targeted groups, like customer
Yeah.
support in this case, or
Mm.
the IT department of the company that where your product was deployed and things like that. So when you look at AI today, it's front and center of everything, whether you like it or not, whether you are ready or not, right? So what kind of factors are influencing AI adoption? What are you seeing as challenges?
Yeah. AI has evolved over the years, right? So we have definitely started from a point where you didn't typically have enough data to work with, to having the even the other extreme of having just too much data. And in fact, one of the challenges is also to have data in a usable form, right? Like be it feature engineering or making sure you have the right features. Yeah. So basically, those are different factors there, having the right kind of data to make it work. Of course, model accuracy is another factor which a lot of use cases are highly reliant on. Um, Business applications also mean the ROI needs to be, understood appropriately, right? So those are definitely key factors. Another important factor which comes in is also explainability. This is basically what explainability means is that you understand how the model works and its decisions, right? So I can give you an example here. Let's just say that the regulatory industry, right? The first one would be around regulations. So if you as an individual, if you have been denied a loan, right, there are regulations in a number of regions and countries that the loan denial can be contested, and the organization should be able to provide the background on why was it denied, right? So that's where explainability comes in here, which means if the loan was denied, the individual has the right to understand how the model worked and what was the rationale behind the denial. So that's one area. Similarly, building trust is another important factor. Like let's say if you have a medical imaging industry, right, where you are identifying certain diseased areas in the scans, or you could also look at autonomous driving, right? So you want to build trust in your model. What this means is that you're trying to identify what parts of the data is it highlighting on. A classic example which is cited quite often is, let's say you have an image of the street view, and the image is rightly identified as being a traffic light, right? The object in the image is rightly identified as a traffic light. But when you do an explainability test on it, right, like you run the right methods and techniques, you find that it's focusing on the trees behind the traffic lights and not on the expected object as we perceive as humans, right? So that's a clear sign that there is probably a need to retrain the model with the right data, maybe more images with traffic lights and without traffic lights. So those are clear points. So building trust in the system basically means explaining how and what is it focusing on, and there are different techniques within this space. Similarly, the last and equally important point is fairness and bias, right? I mean, when you look at models, making sure that it's, what are the features it's paying attention to, right? The similar example, if you're looking at loan disbursement, is it focusing on factors or features like gender or race? Could that mean an implied bias, right? And how do you bring about bias mitigation? So all of those are different factors which fit into explainability, a very important and relevant area. I mean, just as important a few years back as it is now. Yeah, in fact, yeah. Yeah, go ahead.
How have you had the opportunity to use explainability, and how have you established, let's say, trust building with customers, and what have you seen as reactions and perhaps takeaways for you from such conversations?
So explainability is something which it can happen at different layers. Like as an data scientist who's building the model, you have a certain set of priorities and ensuring that the model is fitting within, say, the right bias and fairness parameters. That's one goal of it. The trust factor basically means that as you're building the model, you could be working with the SMEs, the experts, to ensure that the model is focusing on the right parts. And then when you need to do a retraining, you do the retraining accordingly. So those are the different parts that we would typically look at, right? Like making sure that each of these is working as expected. Regulatory is more of an end user requirement where the users would need it. So the way it works is explainability. There are some models which are, we say, interpretable, like because of the way they are, like say a regression or an decision tree is easier to understand because it's something as a human that we can easily perceive and understand. But then there are other models, like say the deep learning models, which are a lot more difficult, right? Complexity is definitely there. So then how do you maybe look at the decisions and find ways to understand the model? Probably either focusing on the decision and finding similar kinds of local spaces in and around it. So different ways, different techniques, and it's definitely important. And like I said, both at the model building phase as well as later on. I mean, just to add a quick plug here, I've just written a book on interpretability. So the book is titled Interpretability and Explainability in AI using Python. So I do cover a lot of those topics within it. There's also a chapter on Gen AI interpretability or explainability within it. It's definitely a newer area, but extremely relevant and important as well. Yeah.
Congratulations on your book, Aruna. I'm sure it'll make a very interesting and exciting read. Do you have maybe one or two things on interpretability and Gen AI that you can share with us?
Yeah, so definitely. I mean, this given that the whole space has evolved so quickly, Gen AI, the focus of interpretability in Gen AI is also getting more and more stronger. To start with, when you look at Gen AI, the basis of it is transformers, right? It's built on most of the large language models or the multimodal models have transformer as its base, which means we are looking at the first point of the first starting point is looking at can I make some sense of how the transformer works. Again, there are two parts to it. The transformers, maybe you could look at transformers from a scale point and say, if I have a small transformers, a lot of which were from the yesteryears kind of models, the way you perceive and look at it could be different. Like explaining those models might be relatively more possible than the models that we have now. Like we're looking at billions of parameters and maybe even trillions soon. So the complexity changes drastically between the two types of models. But having said that, there are still some techniques like I don't want to get into the details of the transformer architecture or how the Gen AI models work, but there are layers like say what are the key features it's paying attention to, very similar to what we were doing earlier. But here we are looking at features in terms of the words in a sentence, right? So what are the words it's paying attention to? A classic example is it relating a noun in the sentence to the pronoun, which is probably much further down, but they are related, right? Like, or is the verb being rightly associated to the person indicated in the sentence, right? Like a classic example given often is the chicken could not cross the road because it was too wide. It is referring to the road, right? So those are different parts to it. One instance or one thought process is let's just look at that. You can get much more deeper and say let's look at the neurons itself within the neural architectures. Are there any kinds of activations which are giving us some sense of what is happening? Then again, there is this whole layer that you use the feed forward networks, right? So the gradients have some kind of a story to tell. So there are different parts to it. Sometimes it is possible that each one is telling a different part of how it works together. But yeah, this area is extremely interesting. I think the research that is coming out is super interesting. There were a number of recent papers also which came out talking of making sense of concepts within the models. Yeah, this area is going to get much more deeper over the years. The research is the research community is extremely active, doing a lot of things. Of course, the biggest challenge is the scale, and let's see how things go. But I think there's a lot more coming. Definitely, a lot more exciting things coming, specifically in understanding, the LLM models. Yeah.
Yeah, I think there's a whole lot that merits perhaps a series of mini episodes by itself. In fact, I know I'm now listening to a lot of AI podcasts that are just 10 minutes with just enough information. And I'm also sensing that there's so much coming down the pipe. It's actually getting very hard to keep up.
Yeah,
So
FOMO.
yeah. No, I think more than FOMO, it's also how much is when I look at
Yeah.
adoption, I'm sure every business must be thinking, yes, there is FOMO. Let's see how we can get onto this AI bandwagon. Um, and I'm sure they all understand that it's not like a flip of a switch that overnight or the waving of a magic wand that something will just transform miraculously. So, what do you see as, impact of Gen AI and agents, particularly to help businesses begin or set them on a path of adoption of AI into ways that can genuinely help their businesses improve?
Yeah, so the impact is pretty clear. I've seen this over the past 3 years. Like as the models evolved, we also started to think, more ambitiously as well in terms of how do we build bigger systems with more impact. So impact is pretty clear. It's happening across functions and industries. Some industries definitely adopting it faster, but at the same time, the value is still there across the board. Like for instance, let's take like let's see, right from responding to a query, answering a question, summarizing a report, to be even being able to generate the report, right? Like the report could be generated with just inputs from multiple different sources, right? So you can do the spectrum of things, right from a very basic task to being able to make it more evolved. And that's where agents can come in, right? Like a few years, couple of years back, we looked at more of isolated tasks. How do I make that better and make it work? Like maybe a generating even creative images. So all of those were very specifically isolated kind of tasks. But when you start looking at agents, you're looking at how do you piece it all together, right? Like how do you make it work in an orchestrated way, and maybe even taking on a bigger goal or an ambition, right? Like the same example, maybe we can look at, say, you want to build a report for an RCA, right? The root cause analysis of an incident. So you could take it a step further and say, don't just build the RCA report, you also email all the stakeholders and record the feedback, right? Now, without realizing, this sentence has many different parts to it. One is actually pulling in information from different sources. Then you generate the report, which the model may have to do. Then you have to look at emailing the stakeholders. Now, and the unspoken part is identifying the stakeholders, right? That's something which maybe the agent has to be smart enough to know that I have to identify the right stakeholders for this incident and then email them, right? So there are different parts to it. You can have agents which have access to the right tools to do it. So without realizing, we are completing and accomplishing goals, right? End-to-end goals. And that's where the impact is going to be, right? Like the fact that you are now completing tasks which may have been very repetitive and something which was taking up a lot of power, mind power and time for individuals. So those are definitely good starting points. But of course, this is just the start, right? I mean, this is just the start. There are many different areas where you can start looking at using agents, specifically Gen AI and agents. And the complexity is, of course, the fact that the models can themselves reason and build the plans, right? That's where the power comes in. The fact that it can even build the plans and orchestrate it versus just using some kind of a ruled systems. So that's the real power, the fact that the models can be the orchestrators of plans to achieve goals. And that's where agents are going to be key. Again, agents could be just doing a single task, or it could be doing, a complex evolved task where you have multiple agents working together. That's where the multi-agent systems come in. But yeah, the impact is going to be clear across industries, be it manufacturing, the factory floors, or you look at different industries, definitely the impact is there. BFSI, again, has a lot of these regulatory requirements, risk, and all of them. So the areas are immense. Of course, the creative side is, again, another big area, right? The fact that you can create as well, generate, use the generative side of it. So the impact is, pretty tremendous. Right now, the way things are, there's a lot happening in all of these areas. Like the models are getting extremely, evolved and better. We have a lot of different types of models. The frameworks are getting much more complex and able to handle more of these areas. Similarly, the tools and platforms are also getting a lot of attention, right? The way things are going, I think pretty soon in the next couple of years, the adoption is going to pick up big time, right? So if it's just started now, it's going to get much more, prevalent for all of us. We may not even realize that we have an agent in our midst.
Yeah, I actually have to plan for a short trip, and I'm wishing I had an agent. Well, I'll say, okay, book me a flight. This is the times, my going, coming. Take care of all my booking. This is my budget. Just do everything, please, and just present me with two options from which I can pick.
Yeah, I think I'm sure it's here soon, and we will get hooked to it.
Yes,
I'm pretty sure we'll get hooked to it. Yeah.
definitely. I see myself getting hooked. So I think this is also a nice segue into a burning question for many, many young folk.
Mhm.
There seems to be a lot of fear. I don't think of missing out, but more around how can I prepare myself for AI-driven future? What does a career in AI look like? So what would you share with people either aspiring to figure out how to live with AI and adapt to it, or people who are already in the industry for a long time, but hey, want to perhaps make a switch? What would you leave them with, Aruna?
Yeah, no, that's a good question. I do get asked a lot of how do I move into this area, and of course, the early years, getting into AI meant that you might have to do a lot of, getting into the core models. Now you also have a range of possibilities, like you have pre-trained models, which means you have a different persona of people also being able to get into AI. Uh, I would look at it in two different ways. One is, you could either be full on and get into the midst of AI, getting totally hands on and doing a lot of stuff in it. That is one route, going on to the deep end, getting into AI. The other path would also be to look at how do you make it play to your strengths, right? So, like, there is a lot of ancillary areas within AI, and a lot of times because we see, uh, the focus on the AI and the models, we just assume that's the part where there's there is potential. But really, there's a lot that's going on even in the ancillary areas, and that's one area where you can pick up, play to your strengths, build a niche in that space. So you are actually uh, uh, adding value right from the day one while picking up a new skill. Of course, skilling on AI is going to be imperative for all of us, but at the same time, how do you make it work for each of us could be different, right? How do you make it work and work well, right? So that could be different for each of us, and that's where I would say being a little, aware of which end of the two spectrums you want to get into is key, and then play to your strengths. That's one of the things I really believe, that use your strengths so you can make a new technology or a new skill work better for the others as well as for you. Yeah.
So would you recommend some kind of a SWOT framework to work with AI?
Yeah, definitely. Maybe that's something we could come up with. Yeah.
Yeah. Yeah, I also feel that, right? When you actually reflect upon yourself, I think and give yourself the time to do it, you actually come out with the best answers,
Yeah.
right? It,
No,
it, it
that's true. Yeah.
yeah.
That's
And
very true. I mean, yeah.
like you said, I think I would go back to your very opening
Mm,
statement to say that, um, if you've actually lived your nightmare, and let's say
mm,
that your job being taken over by AI, you being becoming useless and redundant, and you are actually living through it.
yeah.
Now's a good time to do something like this, isn't it? And
Yeah.
then figure
No,
out,
I
yeah,
agree, actually. I mean, that's totally true. I think each time we have to reinvent ourselves, you don't realize that probably being pushed to do something better, but it could always be better if you go it with the right mindset. Yeah.
yeah, yes, I agree with you completely. And with that, we've come to sort of the end of this conversation. Want to say it's been fantastic in every sense of it. These are very, very interesting times. I know it sounds cliched, but it's always fascinating to explore someone's experiences, with AI and where it's headed. I think the possibilities are tremendous. So thank you so much, Aruna, for sharing your thoughts and your experiences with us today.
Yeah, thank you, Chitra. I mean, likewise, I had a good time as well here today, reliving a lot of the early experiences as well as talking AI, my favorite topic at this point, maybe for a long while now. But happy
Nice.
to talk.
Keep
Yeah,
it alive. I'm
yeah.
sure we'll circle back for a few more conversations. But thank you so much.
Thanks. Thank you. Thank you.
We thank Siddharth for the music and Anita for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.